Good afternoon. Can you hear me? Good. So welcome back, everyone. Great you stayed, not just for the drinks after that one. My name is Benjamin. I'm a lecturer at the University of Edinburgh, just across the road. I'm in Informatics, but I'm also part of Design Informatics. And I want to talk about tools for data visualization today. That's what we're doing in our research a lot. So what exactly is data visualization in research? So we're trying to use scientific methods to explore how data visualization can help data discovery, how data visualization can help exploration, communication, engagement. It's a wide field, a wide area. You just see just some of the techniques and the recent work that we're working on. Don't want to go into detail at this point. But we're trying to use analysis, task analysis, to try to see what problems do people have in biology, working at the government, NHS, statistics, in brain science, in biology, all these fields. We're trying to identify their tasks. What are you doing to the data? What are you doing with the data? And it's actually great to speak after Anastasia and Alex, because they kind of mentioned some of the problems that we're trying to solve with data visualization. For example, this clustering problem, to look into your cluster, to try employ visualizations to see where these clusters are similar, where are they different. So we then try to design techniques to cope with these problems. How do you visualize all these tons of clusters? How do you visualize what's in the clusters? How are the clusters similar? How are they different? These kinds of issues. We also implement tools. Most of the stuff that you see here has some sort of code behind it. So we run the code on the different data sets. We can see how does this actually work. And it's complementary, again, to what Anastasia said. You have heterogeneous data, so you want heterogeneous approaches. And a lot of data is very unique, in a sense, or has unique characteristics that require very, very specific solutions to data visualization. We also then evaluate these tools, techniques, designs, call it whatever you want, to see how effective they actually are. Do they support humans in that task, in solving the problem? Do humans see the patterns that we want them to find in the data? Can they make assumptions about the quality of the data? Can they find new things? Can they discover things? And of course, we're building theoretic models around it, trying to improve the design processes, trying to figure out what works well for certain data sets and so on. However, today, I don't want to talk about all this research, which you can find elsewhere. Today, I want to talk about tools. And why I want to talk about tools is there's specific reasons. One reason is that in my research and my work, a lot of people asking me, how can I visualize X? Okay, I don't know exactly what tool you can use to visualize X. I can help you building a tool, but there are already a lot of tools out there. And what I mean by tool is something that extends your human abilities, because humans are tool builders to simplify their life. We always want to make things simple. So we build a lot of tools for different things, and they do different things. So they extend our perception, they extend our forces, they extend our physical capabilities, and they allow us to use energies in different ways that a human can't do. So tools simplify our life. And in one sense, visualization is a tool. It's a tool, it's a methodology that allows us for discovery, for understanding, and for communicating data. So much like microscopes, if you will. The microscopes, they allowed us to see invisible things for the first time. We could grasp what is in the brain, what are these tiny little bits that the brain is made of, what are bacteria, all these things. For the first time, we could see this. And since then, of course, scientific tools have been evolved and developed into different branches. So what I want to say is that visualization is one of these scientific tools. It's like modern microscopes, if you will. And it's not just the microscope. It's not just something that you can see. It's also something that you can interact with. I'm just having one of our projects here, which is a very interactive approach to data visualization. So you have this kind of cube, and you want to explore this cube in interactive ways and see, watch it from different perspectives, to get different insights, and to do interactive exploration. So, in order to create these visualizations, we need tools in order to build visualizations. If we start with data on one side and we want to make a we want to make it a visualization, we need this kind of a visualization tool where we can load in the data and then we create it. A visualization comes out in a very simple way. That works for many different data sets, maps, networks. There are many, many tools out there. On the other side, many tools are still missing for specific data sets, as I already said. So then you want a design tool that creates your visualization tool that then creates your visualization, sort of. So I'm going to reuse these two terms during my talk a little bit. But what exactly do I mean by tools? So there is a growing number of tools that are available to people to create their visualization, to do their exploration. And I'm just putting these here. These are some of the tools that I can a little bit talk about today. It's not meant to be complete. It's really just some tools that I came across in my research, in lecturing, and talking to people. Some commonly available tools that do a good job in creating visualizations and helping with data exploration. Now, who of you know at least one of these tools? Okay, that's good. More than 3? More than 5? Okay, good. So I'm really, really interested in knowing your opinion and knowing what you think, what you can recommend about these tools, how can we build better tools in future, where these tools are limited, but of course, when to use a specific tool. So where is a specific tool good? Because I think there's a huge demand in building such a knowledge source that we can recommend tools for different aspects. Because all these tools, those of you who know more of them, they differ in a variety of characteristics. The visualizations they create, the aesthetics, they differ in the way they're interactive, the way you need coding to create any specific visualizations. Some of the tools require heavy loading or libraries. The other ones are on the web, and you can just load your data and get some visualizations. They differ to the extent of their scalability and how performant they are, and all sorts of different things. So I want to really just try to give an overview of these tools for you to take home an overview of tools. Okay, there is a growing variety of tools out there. How are they differing? What are some of the characteristics that these tools have? And what sort of workflows do they require? And again, I'm not meaning to be complete here. It's just some of the tools that I know. And in order to structure this talk and thinking about tools, I thought about the tool space. So why don't we just try to divide the tools that require coding and the tools that require using it. So we don't need any coding for those of using. There is also some tools in the middle which require designing a visualization first before you can use it, but it doesn't require you any coding. This is a fairly new set of tools, I'd say, so I'm going to talk about them at the end of this talk. And on the other side, we could say, well, there are tools that are very generic that allows you to create a lot of charts, a lot of visualizations. And on the other side, they're very specific for networks only, for time series only, these kind of things. So we can now populate the space with some of the tools that I have. So on the generic tools that you can use and create simple graphics, but a fair amount of them are raw graphs, Data Illustrator, Tableau, Data Wrapper, these kind of tools. On the generic and coding side, we have data-driven documents, D3, Plotly, Unity, bokeh, processing, all these tools. For the coding, specific ones, I won't talk about them today too much because it requires a bit more than a 30 minutes talk. Mapbox and Leaflet are common libraries for creating map visualizations with lots of data points. And the specific tools for using, I mentioned some of them if I have the time, because we're personally developing some. They're quite interesting because rather than these generic tools, the specific tools are much more powerful in a way because they are much more tailored towards a specific type of data set. Okay, so let's try to move a little bit through the space and see what we have. We're going to start with the static tools for using. And I want to start with Data Wrapper. Who knows Data Wrapper? Wow, good. I can tell you something new. I thought you know this. So, which is good. So Data Wrapper is a tool that is mainly made for journalists who create interactive graphics for their websites. And I should have a video which starts itself. here we are. So the way Data Wrapper works is it takes a set of data sources that you can upload. It's like CSV files or Google spreadsheets. You can link them. Here, just for trying, you can go to the website. It's free to use. And just choosing one of the example data sets on the gender pay gap, it then formats these in a table, and we can see, is this table complete? Is our data complete? So it's a bit of an exploratory exercise in the beginning, so we can see, are there any distributions? What is the distribution on the side? Do we have extreme value? Something that we want to fix before creating the visualization. And then it just proposes us a visualization for this gender pay gap. So it analyzes the data, it finds what fields we have. And here it creates this kind of chart. We can then see how that works on different devices, because again, it's for journalists mainly who rely a lot on users on their mobile phones. But what's really interesting about Data Wrapper is on the left side, you can see all these tiles with visualizations. And while Data Wrapper just proposed as one tool, one visualization, we can also easily switch them. So we have this kind of range plot, and then we can click on any of these tiles to get another view. And then it just changes. We can explore a little bit. It does not work for all visualizations, of course, because a single pie chart might be a bit hard for this data set. But in this one, it works quite nice. So it's a very explorative process. You can then explore some others. You can then have, you can see these kind of tabs on the left side. It's about refining. You can then annotate your tool, add the title, change the titles. For example, there's an error. It says liquid fuel and woman. So we're going to correct that. It also has these kind of color blindness checks on the bottom. So once you refined your chart, you can assign different colors, like here, doing a lot of styling, and then checking whether this is a colorblind solution, a colorblind safe solution that you have picked. I'm going to talk about color later on, because it's an important topic, and there are many, many tools for coloring charts. Eventually, you can then just embed this into your website and yeah, put it up there. The drawback, so this is free to test. And it works for, I think, every day you get a new try in your browser. If you have two browsers, you get 2 tries. I didn't say that. But otherwise, you pay for it to use it. However, it's really powerful. I think it is a very powerful and easy to use tool. Now, if you're into this kind of drag and drop interactions, because that's really the interesting thing about Data Wrapper. You don't have to code anything, you just drag and drop. You want to try Polestar, which is a tool from the Interactive Data Lab at the University of Washington, who creates these kind of scatter plots by dragging and dropping your data dimensions onto the axes. You can then use specific styling techniques, applying color, size of these marks, shapes to encode whatever dimension you have. You can set them into rows and columns if you have a multi-dimensional huge data set. Again, I invite you to play around with this. It's very simple. This is entirely open source to use because it's research. So talking about charts is, if you look at these ones, so we have scatter plots here, and in Data Wrapper we have a set of charts, bar charts, line charts, stacked bar graphs, whatever you want. But there are a lot of problems that require to go beyond these sort of, let's call them basic charts for the moment. For example, tree hierarchies and trees, Sankey diagrams, specific timelines, networks, all these kind of issues. So if you're into more exciting graphics, let's say it like this, you can go for RawGraph. RawGraph is, again, an open tool, RawGraphs.io, and it works similar to Data Wrapper. So you upload your data or you use any of these examples that are provided. You get a table view. You scroll down to see these kind of visualizations that they provide. If I can stop the video here. So you can see they have tree maps, they have circle dendrograms, they have B-Thorn plots, cluster dendrograms, circle packing, parallel coordinates, tons of pie charts, horizon graphs, And I'd invite you to just explore with these graphics if you like. If you're happy, so here you have to choose your mapping yourself, rather than having a computer suggesting anything like in Data Wrapper. And then you just assign your data fields in green to the visual mappings that they should be, that you have in your visualization. And then here we get our chart on music values, a simple time series chart evolving. What's good about raw graph is you can export these graphics and then work on in Illustrator. So putting all the labels, fixing the colors, sizes, and so on and so on and so on. It's probably mainly a work for graphic designers, but you can pretty quickly get an impression of your data if you do not want to use it for any presentation. But if you want, you could go ahead and do it. Okay. There are certainly more tools, Tableau, Power BI, Microsoft's tool in this area. Let's look a bit about the generic and coding ones. Those of you who use Python, they probably know Bokeh. Bokeh is a library to create graphics. It can be fairly low level, so you can place specific marks on the screen, similar to data-driven documents. You have a huge set of templates online that you can use in your Python, but you have rather very low level control over these graphics. Plotly is similar. Do you know Plotly? Who knows Plotly? So it also works for Python, it works for R, MATLAB, and so on and so on. And it creates interactive graphics, while Bokeh basically creates static graphics. So here you have then interaction where you can see labels and get more details. You have pan and zoom and all these issues. And again, you have a library of templates that you can use, a set of library. Now, data-driven documents is my personal favorite because it allows you very, very low-level control over creating graphics. You basically create marked circles, then you change their sizes, their colors, depending on what they should represent in your data. It runs on JavaScript, and it's basically publishable on the web. I'm sure many people of you have already tried it or have seen any of these three visualizations. Now, the advantage is really that you have a lot of routines for importing data. If you use other graphics libraries for JavaScript, it may not be that easy. You have these objects and a visual sort of a language for objects and shapes and changing these values. It's based on jQuery, so it's manipulating your DOM. It has a lot of convenience functions for visualization, such as color mappings, scalings, logarithmic scales, all these issues, which makes it very easy for prototyping. Of course, you can't build huge applications and big data visualizations because it's all running in SVG, so your browser will have a hard time at some point. What's also good is there are tons of examples and a huge community that help you with tutorials and so on and so on. On the back side for this one, it's a bit tricky to learn, and I always like to ask how much people think it takes. But it's not something that you learn as quickly as a Python library, just to get your head around a little bit. Yeah, that's actually an advantage. There's tons of libraries and tutorials, and it's powerful and nice. So I can only recommend this. So let's look a bit about these tools on the bottom, and I want to go into just some examples. Jeffy is a tool for graph visualizations. Who knows Jeffy? Some. So it's really easy to use. You can import your graphs in different formats, GraphML, whatever other graph format languages there exist. And it's fairly scalable to big graphs. What you get, you can also do graph analysis, network analysis, and clustering, and this is what you see here in these colors, showing the different clusters in this network. One of the drawbacks of this one is that you often get networks like this, which are to some extent limited because they suffer from a lot of cluttering. So you see a lot of overlapping links. They even removed all the labels here, so it's hard to support any real analysis tasks and exploration tasks. So in order to overcome some of these problems with this type of representation, it's not a problem of Gephi, it's a problem of the specific node link diagram representation. We are currently developing the Vistorian, The Vistorian is a platform, an online platform. It's also open source, which focuses on network visualizations for historians in the first place, but it probably works also for biologists because networks are networks, and it depends on how you interpret them. So in this example, we're focusing on networks with lots of different types of edges. These are different types of letters that people have been sending. Networks that change over time. So on the right side, you see sort of a change perspective on this network. Rather than a node link diagram on the left side, we have a sort of a timeline going right and all the nodes going down. And then we can see when they have been sending these individual letters one to the other. So we're exploring different perspectives on the data with this Vistorian multiple complementary visualization. Again, data import is very easy because we're mainly want to design this for an audience who is not able to code or who does not want to code and spend the time in coding. So you import your data here, assigning your elements to what you in your data table, how you want them to be visualized, and then you can just click on the visualization. So here we have this also node link representation, but it's dynamic, so we can change the year that we're looking in and see how these connections, these social connections, change over the years. So that is very simple. We have then also other representation, which at this moment I'm running a bit of time out of time. So I invite you to play around with this and to give us some feedback and get in touch if you want to use it. All the presentations, all the different representations you can see here. We have a map visualization, we have a matrix visualization in the center, which is much more powerful for networks that are very dense because they do not have any, they don't suffer from edge occlusion and overlapping things. Okay, if you're looking for geographical visualizations, there are a lot of tools that help you building geographical visualizations. I'm taking this from datavisualization.ch, which is a great source of tools. I just want to show you the variety of the tools that are there for specific temporal visualizations here. You can find more also on data visualization, focusing on specific charts. This Cubism.js uses a visualization technique that is called horizon graphs, which is really good for multiple time series that have a lot of variation and uses a kind of an unusual encoding, but it's fairly easy to learn. Okay, so I also want to talk a little bit about presentation and infographics, just to give you an impression of what's possible with today's tools and what approaches exist. So I already said that in raw graphs, you create the base graph, then you export it, and then you go on with Illustrator. Now, Data Illustrator is sort of an approach from Adobe. It's Adobe Illustrator from Adobe Research, which allows you to drag and drop and to sketch your visualization yourself. So I want to show you how that works, because it's kind of a new paradigm if you think about the other tools that I've shown you. So we load our data set, we get this blank canvas. We see there's tons of data. We got states in the United States, and their obesity and the bachelor's degree. So we just start dragging and sketching a line here, and then we bind this glyph, this visual element, to all the states. So in a second, we're going to see we have 50 states. We have 50 lines. So this is a very simple binding. And you can see that you can just play around with these lines and say, what are I going to do with these lines now? So they're all following the cursor at this point. But what we can do now is we can bind data dimensions. So here what we're doing is we're binding the obesity rate to the to the y coordinates of the right control point, and we see the lines move differently. And we do the same for the left side. So here we bind it to the BA degrees, and we have now sort of a chart. So the lines on the left side, they are aligned. To the BAs, the rate of BAs, and the right side is aligned to the obesity rate for each of the states. That's fairly simple. And now, in this example, this is a video, by the way, so you can find it online and have pretty good documentation. You can choose now different colorings for all these states to make it more clear which states are having more, are higher on obesity and less on the college degrees, and you can see this kind of inverse correlation in this example. Again, you can then add labels and make the chart readable and understandable, all in this Illustrator. And I'm not saying this because I'm making advertisement for Adobe, but because it's colleagues who developed this. And I find it quite a nice way of a nice approach of creating visualizations. Charticulator is a similar tool if you want to try it. I haven't tried it myself, but it promises similar functionality. Now, I want to talk quickly about coloring, because coloring is important. You can do a lot of things you can do wrong. Those of you who have ever come across the problem of trying to find a coloring scheme for specific visualization or specific presentation or anything, Color Brewer is a very nice tool. It's developed by perceptual psychologists and geographers to find color scales that work well on maps. So in this case, we have a sequential color scale. So you can say, I want to have I want to get 9 values in a diverging scale, so from bright to dark, and you get all the colors that you can choose here. You can also choose a diverging color scale, which goes from one dark value over some bright values to the other one, if you want to show warm and cool, for example. And you could choose a qualitative color scale, which gives you a set of views which are meant to be perceptually equally distant, so that that there is no real order that your perception implies between all these values. So you would say they're fairly distinguished colors. And this is really a problem, finding good color palettes and distinguishable colors. There's another tool which is called I1U, which you can find. It's from the Media Lab in Paris. So here you can choose your color range, the color palettes, the colors you want, and then they employ a specific clustering algorithm to get you 5 views out of this. I'm not saying that these ones are all perceptually correctly independent, but it probably gives you some nicer color palettes, some more harmonic color palettes than the Color Brewer, which is optimized for perception. And sort of to finish off, 2 toolkits that we are working on immersive environments. So immersive environments where you build your visualization, your data visualizations in virtual reality, in mixed reality, augmented reality, these kind of new technologies. And there are 2 tools that are still in the research phase, but if you're interested, please contact us. But at least it shows us that there is a new need to design visualizations to facilitate the creation of visualizations in virtual reality. So on the right side, you see these 3-dimensional structures, 3-dimensional charts. On the left side is an example for mixed reality, where we project ingredients into a supermarket. There are more tools, of course. I'm not talking about more of them. I just want to say this kind of datavisualization.ch website is pretty nice. Has tons of tools, some description. It could be a bit more. You can also go to my website. I'm trying to collect tools that I personally use, and I can give a bit more advice. However, there's a huge gap in evaluating these tools, in communicating these tools and discussing them, what is good, what is bad. So I'm really interested in your opinion, which tools you would recommend for which cases. And the tool space as well could probably be then extended to include all these other attributes that I have mentioned. So how scalable are these tools? How easy they are to learn? How aesthetic are the visualizations that you can create in the end? And let me finish with this. One high-level impression is the best tool, if you're overwhelmed by the set of tools that they are, or in general, the best tool is pen and paper in your hand, because you can express yourself very cleanly, very clearly. It is not expensive. It doesn't take you anything to learn. You can explore design spaces. You can communicate your visualization. You can even just draw your data visualization on paper. If you know Dear Data and their exhibition at the Museum of Modern Art in New York, then you know what I'm meaning. This is a napkin visualization which won a prize, so it's really easy. Everyone can do it. And I want to invite you to do this. And if you want more, if you're more interested in visualization in Edinburgh or in the world, then either join our DataVis meetup in Edinburgh once a month, or visit this VisGuides forum, which is an open forum which we want people to use to discuss visualizations, designs, problems, tools, getting advice. So we have a huge research and design community behind us who are trying to answer your questions. And at this point, thank you very much for your attention, and hope to see you soon.